Hello folks, today gonna make a tutorial video for PD, continuing my series. This time I'm gonna talk about taking a sound file and looping it, which is quite fun and interesting, and it opens up a couple different things. It opens up the idea of playing with sound in a more, or sound files in a more kind of liquid kind of way, rather than just playing a sound and listening to it from start to finish like we've been doing before. It also lets you do, so now you can play, you'll be able to play things at any pitch you like, and also play them reversed and things like that, and loop them. And also it will very easily lead to recording samples yourself. So I think I'll do that separately, but first we'll just get a sound looping. So the very first thing that I like to do with this is just save my patch to start with, because that way it knows where it is and it will be able to reference sounds. So I have a little folder already that I used in the last one called sounds. So in my Sound Games final project folder, I'm going to say bonk tutorial 4. And that way it's there, and now I can I know exactly where my sound files are, and I can reference them really easily. So the way Pure Data looks at sound files is by using arrays. So an array is also kind of interchangeably called a table. The difference between them is it doesn't really matter. It's basically the same thing we've been using for like our sequencers and stuff like that, except for instead of having 16 steps, you'll have 16,000 steps or 160,000 steps, like way more. And it just takes a sound file, loads it into, what you want to do is take a sound file, load it into an array so that it's turned into a set of data points, and then work out how to read that array. So as you can maybe guess, the first thing to do is to make an array. So I just did Shift Command A, or you can go up here, put wherever it is, down at the bottom, array. And I'm going to rename it sound1, just because I'll remember that. You don't need to worry about the size. I'll show you why later. You don't really need to worry about anything else. You can click OK, and at least in my version of Pure Data, there's this weird bug where you have to move it before the title comes up. So there we go. Sound1 is there. So that's our array, and that's what we're going to use. Now it's always good to make the array first before doing anything else, because otherwise you'll start seeing error. Confusing. Now the object, there's a kind of, just made a message by accident. There's an object that's used as the sort of management, as the sort of in between your computer and the sound files you want to play and the array. And it does all the kind of the boring stuff basically, and it's called sound filer. You only need one of these in your patch, but you can have multiple if you like. So the sound filer object is what you tell. And so what we're going to say is, hey, go open up this sound file and load it into our array, which we're calling sound1. So the message that you need to send sound filer using a message box is read. That means read a sound file. And you have to put a flag in called resize. So a flag, you use the hyphen. So it's hyphen resize in one word. And what that does is it takes the sound file and makes the array as big as the sound file is within some limits, but even those you can supersede if you really like. I think it limits it to, I forget what it is, a couple minutes or something, but there are ways around that. But in any case, what resize does is, so right now our array is only 100 steps long. That would be like 1/44th of a second, so a very teeny tiny sound. But if we use read space hyphen resize, whatever sound I put in there, the array will become that long. And then I put the path for the sound file. So we're going to use sounds/musicbox.wave. I think that's what I called it. And the last thing you need is you need to tell it which array you're loading that sound file into, because you can have multiple arrays, right? You could have 10 of these arrays. We only have one, but we still need to say we want to load it we want to load musicbox.wave into sound1. Now it's really important you always use the exact file name, capitals, the extension, whether it's a wave or an AIF, and the path needs to be correct. So most of the times, if you don't do something, if you get something wrong, it probably has to do with that. It probably has to do with what your sound file is called. And you'll see some red errors in here that'll say like, cannot locate file or whatever. I forget what it says, but it's something like that. It's like, we don't know what the hell that file is. Well, that's probably because you either spelled it wrong, you used a capital something, or you're not referencing the file path correctly. So I've connected that message to the object. And I'm going to do one other thing, which is I'm going to put a number box at the bottom of the sound filer. And the first thing I'm going to do right away is click on the properties for that number box and make it wider, 15 width. That's because the number coming out of sound filer is going to be enormous, and it will just show a little plus mark, and that plus mark just means there's more numbers than the number box can show. I've just come out of edit mode, locked my patch, Command E, and if I click on this, because you can click on message boxes, remember, you click on that, it will load all of this into here. You'll see the sound file, and a huge number will show up there. There it is, 146,157. I don't really need to worry about that warning. And there's our sound. Now what that number represents, the number that gets shot out of this outlet from sound filer, is the length of this sound, but it's the length in samples. So the way digital sound files are created is they have a number of samples, and then there's a sample rate that they're designed to be played back at. So the standard, if you can call it that, is 44,100. That means for every 1 second of sound, there's 44,100 little data points, little samples. That sound, I think, is at 44,100. That means that sound is 2 point something, 3 point something seconds long, because 146,000 divided by 44,100. And that's a calculation we'll have to do later, but that's giving you a length, and that length is really crucial. It's really important for us to calculate how the sound is played back. So a couple other things to show you. The first thing I'm going to do is going to put a send object down here, and I'm going to say send sound1 samples. I'm going to connect these two things. That's because I'm going to use this number a couple times at least, and the more complex of a thing you build, the more likely you're going to need that, like, access to that number throughout your patch. So instead of having a bazillion patch cables everywhere, I tend to find it better to have a single wire that's connecting, or a single send object that's then being sent to multiple receives. Now, a fun little trick. I'm going to make a little bang here, make it a little bigger. And there's another object called open panel, which I think we've seen before. We can connect bang to open panel. And then what this will do is it'll let us pick any sound off the hard drive. So to do that, you just need to make a message with a variable. So it'll look identical to this one up here, except instead of this file path, we'll just put a $1. So it'll be read -resize, and then $1, because that will be the variable that we send it from open panel, and then sound1. Connect those things up. And now I can click on that bang, and I can open up drum instead, and you'll see it changes. So I'm going to stick with music box. But that's just a nice little thing. Now every time I redo that, this number changes and it gets sent out of here. The last thing I'll do over here is I'm going to duplicate this bang. And I often find that it's quite useful to have a bang connected to this number. And that's purely for debugging purposes. That's because very often when you're building new stuff, the objects that you've made don't have this number loaded into it yet. And that number only gets sent out, send sound1 samples, when it changes, or if it gets a bang. So I find very often if something's not working, I'm like, what's not working? Maybe this number hasn't been sent around yet. I click there a few times and hopefully it fixes it. So there's our sound loaded in into our thing, into our array. So now let's make a really simple looper. So the object that we'll use for looping is called phasor. Phasor is actually a wave. If you play it fast enough, it's a synthesizer and can sound like a synth. But it's basically what's called a triangle wave. So it ramps up, or a sawtooth wave. It's not a triangle wave at all. It's a sawtooth wave. When you go, it goes from 0 up into 1, and then it drops back down to 0. So if the audio engine is running, it's constantly spitting out this cycle of numbers. You can imagine it like a circle. If you multiply it by 360, it'd be going from 0 to 360, and then when it gets to 360, it'd go back to 0 again. So if you imagine that to be like the degrees of a circle, it means it's looping around and around and around. So when it's played, when it's quite a slow loop, that's ideal, because what we want to do is make that full cycle take the same length of time that our sound file takes to play. Right? So that's what we need to calculate. We need to calculate how fast should that phasor go in order to play our sound. Now, to do that, we'll need that sound 1 samples. So I've made a receive object, R, and we're going to divide it by the sample rate. Now you can make this dynamic, but for our purposes, because this sound is being played back at 44,100, since it's a 44,100 kilohertz sample rate sound file, we can just put that number in here. If for whatever reason you're using a lower sample rate sound file, this number should change, but I would suggest just sticking to 44,100. That will give us a number, and that will give us the length of the sound in seconds. Okay, so this is a good example of my debugging. I'm going to click here, it'll bang, it'll send this number out, it'll come through here magically and get divided by 44,100 and gives us 3.314 seconds. So that's length of sound in seconds. 3.314 seconds. Now we need to convert that into a frequency. So that means we want our phasor to go from 0 to 1 in 3.3 seconds. That means, yeah, I always find this a little bit mind-bending, but I'll just talk you through the objects that you need to do that. Basically, what you want to do is have it go, is have 1 divided by that number, right? So you have is that the inverse? Oh no, I did really badly in math when I was a kid. So that's why we have programming, to take care of these problems for us. What we want to do is trigger a number, a float, and a bang. Now the float we want to trigger is this number here. So we connect it. If I make a T object, trigger, bang, float, it will send out a number here and then a bang here. This is a pretty good example of the downsides of something like PD, where you kind of have to do this weird roundabout way of doing quite a simple mathematical process, because the way the division object works is it takes a number here and a number here, and this number is divided by that number. But the calculation is only triggered when this number goes through. So we need to click it in order, give it the number it will be divided by, and then send it a 1. We'll have a look at what the number that comes out of there is. Again, good example of my debugging. Click. Okay, it's 0.301 seconds. Is that correct? Yeah, I think that's correct. It's always worth doing a sort of idiot test to like, does that feel right? If the sound is 3.3 seconds, it should take a third of a second, roughly, to go from the beginning to the end. Okay, cool. That sounds fine. So that's the number we want to send to phasor, because phasor is waiting for some kind of frequency. It's now getting that frequency. Again, I'll click the debug so that it's now theoretically playing that frequency. The last thing we need to do is read it, is use this number, this kind of rate coming out of phasor, to then read this sound file. Now, confusingly, the object we're going to use is called tab read for tilde. And confusingly, tab read 4 reads this sound file, but in samples. So we need to get our receive sound samples object back again. This is exactly why I like using a single send and then multiple receives, because we also need that number here. We're taking a number that's going from 0 to 1 and making it go from 0 to 146,157. Luckily, that's quite an easy calculation. Just multiply it by that. So we're multiplying 0 to 1 times our number of samples, and then we're running it into tab read 4, but we need to tell tab read 4 which array we're reading. So sound 1, run this out our sound card, left channel, right channel. I had to press my debugging one more time there. And we've got our sound. Pretty nice. So it's just going to keep playing like that. It's going to keep playing like that because this is just looping over and over and over and over. Now, we can fix that. We can have an on-off button. It's probably the first useful thing we'll put in here. And there are so many different places and ways you can do that. I'm going to show one way which will make what we'll do next a bit easier. Now you notice I've deleted this, but it's still going. That's because Phaser got that number, 0.301, and it's like, great, cool, I'm good. I'm just going to keep cycling this at that until you tell me something different. So what we need to do is make it firstly that this number gets switched on and off before going to Phaser. And also we need to send Phaser a 0 so that it shuts the hell up when you turn it off, right? So first thing we'll do, this is nice and easy, we use the spigot object. Spigot is like a switch. You turn it on and off, and we'll send it a toggle. I'm going to make this toggle bigger, and I'm going to call it start stop. Put that in here. But the other thing we need to do, as I just mentioned, is tell this to shut up. So what we need to have here is a select object on that toggle. So every time it gets it's turned off, so that every time it goes to 0, we'll bang a message box that says 0 and tells Phaser no more frequency. So I'll turn this on, it'll keep going. When I turn it off, this is getting a 0, being selected. It's seeing like, oh, you've just done 0, you've turned it off, and Phaser goes to 0. Okay, now there's a downside to this. When I turn it on, it's also not going to work. I need to bang my debug to send this number all the way through here. So that's a pretty poor implementation. What we'll have instead is we'll have this go into a float object. Here. Actually here will be better. And select 0, 1. So when it's 0, it does 0. When it's 1, it bangs here. Click my debug one more time. Oops, I'm banging the wrong one, sorry. It should bang the left inlet of float. There we go. Okay, so that works. So that's cool. The one last little tweak I'll put in on this before I go to changing pitches and all that kind of thing is you'll notice that every time I click play, it's like picking up the sound, like the sound is sort of looping in the background. Or it starts playing from whenever I just stopped it. I think that's what's doing. Yeah. So if I click play now, it will start like a quarter of a second into the sound. And if I click play now, it'll start like halfway through the sound. So that can be cool. That can be a nice little effect. But if you don't want that, then you can use, we've already got a select 0 and 1 here. And what if you, this right inlet on phaser is the confusingly the phase of the sound. So the phase is like where in the wave it's being triggered. 0 is at the very beginning of the wave. So that means every time we click start, so that's the 1, so that's this outlet, because we've got select 0 coming out here, select 1 coming out here. At select 1, we can send a 0 to the phase. Okay? A little bit weird, but that means every time I click play, it will start the sound back here. Right? Nice. And if I leave it playing, it'll loop back from the beginning. Okay. So, as I mentioned earlier, what this opens up is the nice possibility of changing your pitch and playing around with the sound more. Now, this number here, 0.3, it eventually becomes the frequency of my sound being played back. If I change it, that means it'll either be played back slower or faster. Now, if you hold shift while you click a number box, you'll close it, it'll change. And when you click and slide, holding shift, it'll change very slowly. So you'll hear me do that. I change it really fast. Yeah, that was pretty cool. So it's partially holding down slide there and partially not holding down shift. I mean, partially holding down shift there and partially not. And if I go into reverse, into minus numbers, the frequency is the same, but it's playing backwards. So boy, oh boy, that's fun. To set it back to normal pitch, I can click my debug button. So that's fun. So that means manipulating this number, the number that's being sent into float, that's the one that we're going to use to play with our pitch. Now, the nicest thing to have, I would suggest, is a slider to control the pitch. So let's make a slider, Command Shift J, and I'm going to make it a little bigger. And I'll set the range to be between a negative number and a positive number. So let's say between -5 and 5. That way we can go into reverse, which is fun, and then go into positive number, which is fun. And basically what we want to do is we'll remove this patch cable here coming out of our current pitch. So click on it and delete it. And we're going to have a multiplication object, because that's what we're doing. We're multiplying this number by some other factor, which will then change the pitch. And what we need to do, again, because of the way the mathematics works in PD, is we need to multiply it in the correct order. So we do trigger, bang, float. It's a thing you'll often come back to in pure data. You'll see before I connect this to anything, you'll see that this slider is now going between -5 and 5. It's kind of it's unnecessary to have this number box, but it's useful. We'll have the float, so currently 1.69, going to our right inlet of the multiplier. I might just give this an opening argument of 1. And then the bang going over here. That means every time it gets a new number, it bangs it. So let's press play. And then as soon as I move this, I did something wrong. What did I do wrong? Oh, debug. There we go. Let's do this with a different sound so that we can hear it better. Let's play a little forest field recording I've got. Pretty nice. Just gonna close the door. And again, if you hold down Shift, you can do more kind of granular, small changes. Or let's pick that gun sound file I was using the other day. Obviously, if you make the range of this slider more extreme, you'll get even more extreme effects. If you start playing any sound file more than around 20 or 30 times per second, it'll start turning it into a synthesizer. So you've got kind of like a sort of equivalent of a wavetable synthesizer, which is quite fun. Cool. So there's our pitch control. Let's go back to our music box. It's a little less violent. Now, to tie this into the kind of theme that's going through all of these videos right now, we can use bonk to trigger this really nicely. So let's get bonk going here. Bonk. ADC in there, minvel $1, our slider. I'll chuck the initialize on that, get it around there, and let's have a little thing that shows us to make sure that it's working. Cool, I think my audio settings are right. Okay. So theoretically, we should be able to just connect this bang to this toggle. In my experience, oftentimes you need to actually clean up that bang slightly. So we'll use the trigger object. I find the trigger object just super useful in general, as you may have noticed. So every time it gets a bang, it'll trigger a bang. Don't ask me why, but it seems to work well. I'm going to get that velocity up a little more because I can see it flashing from my voice. And I'll connect that directly to the toggle. That means every time it gets a bang, we'll either turn the toggle on or turn the toggle off. Okay, now remember, what this 0 here is doing is start loop from beginning. So if we didn't want that, we could take this off and then which is kind of like, depends what you're after. They can be two different things. Because our sound here has such a sharp beginning, because it's the beginning of a music box, I'm going to keep it on, because it means that it's quite satisfying when I clap it to have that sound go bang. So it's useful to have. Now I'll do one more trick, just as a kind of proof of concept of what could be interesting. Let's make it so that every time I clap, it not only plays the sound, but it also plays the sound at a random pitch. So this bang that's coming out here, we can have it turn on and off the sound as it's doing, but we can also have it trigger a random number. So let's have it trigger between I don't know. What do we want? Let's say, oh God, why am I finding this so hard to decide? But between 1 and 10. So that means I'm triggering 100 random numbers, dividing it by 10. So it'll be a float value between 1 and 10. And I'll send that. I can actually send it into my slider. Or actually, no, I'll send it into this number box. So that way we can see it. And that means between 1 and 10, so score 0 and 10, or 0 and 9, I guess, 0 and 9.9 probably, we'll get a different pitch every time we play. Fun. Right, so that works. A couple of questions that you might have, I'll address right away. Those were all playing back forwards. You could certainly have it also so that this random number range goes into the negatives and thus plays the sound backwards sometimes. You would just kind of, it's just about working the math out to work out in a way that works for you. So we could make it go between -5 and 5 by subtracting this number. The downside to that you might have just heard there, which is that whenever it's triggered reversed, it's starting from the beginning, from the end of the sound file, which means there's a lot of silence. So it would take, 70% of the sound playback before you even heard the sound. So it's not very satisfying when you're clapping to have nothing happen. For some of the faster ones, it's okay. But a lot of times you might just think it's broken. So I didn't do that, but you can do it like that. Also, people often ask, is it possible to change the pitch of the sound without changing the timing, or change the timing without changing the pitch? The short answer is, yeah, it's possible, but you just have to use a totally different technique. You'd have to use something much closer to the granular engine that I showed in one of my previous videos, because basically sound is a time-based medium, right? So if you're playing back something slower, you'll hear it at a lower pitch. And if you're playing something back faster, you'll hear it at a higher pitch. That's just how sound works. If you want to avoid that, you have to do much more complex manipulation and processing, and either real-time or non-real-time, but it's a much more complicated process. So yes, it's possible, but much more advanced. I believe that's everything I wanted to cover. So let me know if you have any questions. Good luck. In the next one, I'll use the same exact system using phaser and the sampling and the array and all that, but I'll talk about recording sound into the arrays so that you can make your own samplers and then have that be clap controlled or whatever if you like. Thanks.